Hello, my name is Brett, and today I'm going to show you how to set up the RFID module RC522 to read and write to a RFID chip using a Raspberry Pi. In the description below, you can find a link to an article with intro information regarding the RC522. Here's what you're going to need to make this work. You'll need a Raspberry Pi. Here is a list of all the compatible models. You'll need a model RC522 RFID reader, some sort of screen so you can access your Raspberry Pi's terminal, some sort of RFID chipped object. I recommended the tag that should have came with your RC522. If you plan on directly wiring your RFID to your Pi, you'll need 7 female to female wires. And if you plan on wiring through a breadboard, you'll need 14 male to female wires. Our first step is wiring the RC522 to the Raspberry Pi. Your Pi should have came with a card showcasing each pin and their GPIOs. If you do not have this card, you can find a link to an article with a reference sheet in the description below. On RC522, you'll notice each pin is named. We'll call the pin 3.3 volts, pin 1, and increment each pin by 1 every time we go left to pin. First, wire pin 1 on the RC522 to a 3.3 volt pin on the Raspberry Pi, which will either be pin 1 or pin 17. Second, wire pin 2, aka reset on RC522 to pin 22, aka GPIO 25 on the Raspberry Pi. Third, wire pin 3, aka ground on the RC522 to ground on your Raspberry Pi, aka pin 6, 9, 14, 20, 25, 30, 34, or 39. For the fourth wire, we'll be skipping wiring IRQ for this basic setup, and we'll instead be going to pin 5, aka MISO. And we will be connecting that to the MISO on our Pi, which is pin 21. For the fifth wire, pin 6, aka MOSI, we will attach that to the MOSI of our Raspberry Pi, which is pin 19. For the sixth wire, pin 7, aka SCK, we'll be attaching that to our S clock on the Pi, which is pin 23. Finally, the seventh wire, pin 8, aka SDA, we will attach that to the CEO of our Raspberry Pi, aka pin 24. Now you should plug in your Pi, and if you've done everything correctly so far, you should see a red light appear on your RFID, just right there. You should now set up your Raspberry Pi to work with your screen and wait for your desktop to open. Once the desktop is open, open the terminal, and we will now be configuring the Pi to work with the RC522. In the terminal, you'll now type sudo raspi-config, enter, and now you will open the configuration tool. Next, we will go to 5, which is interfacing options, enter, and now you'll choose P4, SPI. It will then ask you if you'd like to enable, you say yes, and now it will give you a message saying the SPI interface is enabled. Now we exit the interface tool, and you should type in sudo reboot, and then enter, and that will reboot your system so that the SPI is on. Reopen the terminal once your system has been rebooted, and now type lsmod space vertical bar space grep space SPI. This will show you this here. What you're looking for is SPI underscore BCM 2835. If you see that, then you know the setup has been successful. Now type in sudo space apt dash get update and wait for it to update. Once the update is finished, we should upgrade all the packages by typing sudo apt dash get upgrade. When you're asked to continue, if you need to upgrade, type in Y for yes, and it will continue and upgrade all of your files. It may take a few minutes for your packages to upgrade, so I recommend pausing the video here until your upgrades are done. Now that all our packages have been upgraded, we need to install some new ones so that we can run the RC522. First, let's install the Python 3 dev and the Python 3 pip package. Type out sudo space apt-get space install space Python 3 dev space Python 3 pip, and it should begin to install these packages. This may take a few minutes once again, so you may want to pause the video here. Now we need to install SpyDev to our Python 3. So we type in sudo pipe3 install SpyDev. Enter. And now it should install SpyDev into our Python 3. And finally, we're going to install the library for the RC522. So once again, type in sudo pipe3 install, and then type in mfrc522. There we go. It has now been installed. And now that we have all of that set up, we can start programming to read and write from our RFID scanner. First, I'd like to show you the location where the installed MFRC522 library should have been installed to. This is because I believe it will benefit you in the future to actually know where these codes are so you can look at them. Let's start by opening File Manager. Now in the file system root, let's go under User, down here. Under User, let's go to Local. Under Local, go to Lib. Under Lib, go to Python 3.7. Under Python 3.7, go to dist packages. And then under here, you should find the MFRC522. Open it, and you will see two Python codes, one called MFRC522 and another called Simple MFRC522. Simple MFRC522 works very well with reading and writing simple chips and returns the data in an easy to read format. However, it lacks the ability to return the data in its raw form and cannot read more complex chips. I will be using Simple MFRC522 for the majority of this demo. MFRC522 is a very complex code. It is difficult to understand and lacks any kind of documentation to help understand. MFRC522 allows you to read and write to more complex RFID chips, however, and it gives you the raw data. Now, open up whatever you plan on using to write your code with. I will be using Onii, but you can use whatever you'd like. Let's start with writing to our RFID chip. First, let's import our GPIO so we can actually read and write to and from the Pi's pins. So let's start by typing import rpi.gpio as GPIO. Second, we need to import our simple MFRC522 library, which is located in the MFRC522 folder. So we type from MFRC522 import simple MFRC522. Now we need to create an object of the simple MFRC522. So you can call this object whatever you like. I'm going to call mine reader, set that equal to simple MFRC522 bracket, and this creates an object that will use the functions within the simple MFRC522. Now we want to get the data that will be written into the chip. For this example, I would like to choose what would be written into the chip. You could, however, just set a static variable equal to some value and pass that instead. So choose whatever you'd like to name the variable. I'm going to choose text. And for my input, I'm just going to do input. And then inside, I'm going to just write something that basically asks for data. New data. Now, optionally, you can do something with a print statement like print place tag so that you know you are ready to place your tag. We should do a try statement for reasons that I'll be explaining in a little bit here. We now want to call a function for our reader object that will write into our chip. In the simple MFRC522, this is called the write function. So type out your object name and then type .write, and then inside some brackets put the name of the variable that holds the data you wish to write. I also recommend doing a print statement that just says something like written, so you know that you have successfully written into the chip. The reason we did the try statement earlier is because we want to include a finally statement. This finally makes it so that whether the pup succeeds or fails in writing to the chip, we can clean up the GPIO pins. If we don't do this, they will remain in use even though we do not need them anymore. So let's type finally, and then GPIO dot cleanup. Let's try this out. Run your code, save it however you like, and then input whatever data you'd like to be written. I'm going to write something like potato, and now it's prompting me to place my tag. I'm going to place the tag, and it says that it is written. So that's great. Apparently, we've written to the RFID chip. But how can we be sure that our data has even been written? Let's now try reading from the chip. Let's create a new program, and this code is going to actually end up being very similar to our write code. Once again, let's start by importing the GPIO. So import RPI.GPIO as GPIO. And then from RC522, import simple MFRC522. And once again, create an object of the simple MFRC522. Once again, we're going to do a try statement. Now here I recommend doing a print statement that just asks for you to place the tag. This time we'll be using the read function from our simple MFRC522 library. This function returns two string variables, so this time let's use two variables. I will name the first one ID and the second one text. So let's type out ID text is equal to reader.read and then our brackets. We don't need to pass anything here as we are just reading. Now let's print our two variables, print ID and print text. For print ID, what we're printing is called the ID of the chip. Every chip has an ID, and it should be a unique ID. Print text will be whatever we have written into the chip. Once again, we are going to write our finally. And once again, we are going to use it to clean up the pins of our GPIO. Once again, let's save and run our code. Here, all we have to do is place our tag on the reader. And once we do, we should see that our system has printed out our ID and what we had written before onto the chip. This is the basics to reading and writing with a simple RFID chip. If you're interested in learning some more about the RC522, I recommend checking out part 2 of this video. You can find a link in the description below, or you can click the title card that should have appeared.